What's up, you guys? Welcome back. We haven't had a video in such a long time. I know you have missed this. I am so sure you guys like my hat. This is my favorite time of year. I like wearing Christmassy stuff. So this is my little microphone. It doesn't actually work like a microphone, but it looks really awesome. So we're going to break this next section down into a few different days. So we're only going to do one example a day. Make sure you really understand it. And then on Friday, you guys are going to have a quiz on the first three sections of this chapter. So Thursday, no school because all the 8th graders are going to be gone. We're going to spend time this whole week working on this section. And this is on page 273 in your workbooks. We are looking at constructing linear functions in section 5.3. So if you guys want to go to page 273, that would be great. I am also recording during the day when people are awake in my house, so it might get a little loud. I apologize if there's any background noise. But on page 273, you can read along. It says a linear function is a function that has the equation of the form y equals mx or y equals mx plus b. So there's not a lot new. We're just looking at it in terms of the concept of functions, which you guys remember that a function for each input can only have one output. Each x can only have one y, but a y could have more than one x. So just a quick recap there. The graph of a linear function obviously forms a straight line. We know that the slope is the m in that equation, and we would also call that our rate of change. And the rate of change between any 2 points is the same or constant. So if I pick any 2 points, the rate of change between those consecutive points would be the same. The y-intercept is b, and in this case, the y-intercept would be 0 because it would be like plus 0 here. So the initial value is when the y value when x equals 0. So again, just a quick recap here. The initial value, our y-intercept is 1. So when x is 0, y equals 1. And then the rate of change from this point to this point, I go up 1 over 2, up 1 over 2. So my slope is 1/2 right there. All right, so you can go to page 274 and look at page 274. You can construct a linear function by determining the rate of change m and the initial value or y-intercept b. So just watch this quick video and you can fill in the boxes while you're watching on the top of page 274. I'll try to move myself out of the way here.
The graph shows the total cost of a cell phone plan each month. Suppose you are asked to construct a linear function from the graph. First, find the rate of change. Determine the rise or vertical change and the run or horizontal change between any 2 points on the graph. Write the ratio of the rise to the run and simplify. For this graph, the rate of change is 75. So the cost of the cell phone plan is $75 per month. Next, find the initial value. The initial value of the function is the y-intercept, or the value of y when x equals 0. For this graph, the initial value is 100. So the initial cost of the cell phone plan is $100. You can use the rate of change and initial value to determine the equation. Use the slope-intercept form of a linear equation. Substitute the rate of change for the slope, m. Then substitute the initial value for the y-intercept, b. The equation of the function is y is equal to 75x plus 100.
So you can see it's really not, we did this in the last chapter. We wrote equations from the graph, and you're doing the same thing, but now it's in terms of a function where we're relating, in this case, costs and months. Now the important thing you're going to have to be careful of in this section is that you're going to have to pay attention to how your axes are labeled. So here this one goes by ones, but this one goes by hundreds. So when we went up 3, it's really going up 300 and then over 4. So it's 300 over 4, not 3 over 4. So even though it's 3 spaces, each space represents 100. So you're going to have to pay attention to what those axes are labeled when you're doing this. So let's look at a couple examples together. This is in the middle of page 274. A shoe store offers free points when you sign up for their rewards. Then each pair of shoes, you get an additional number of points. So this graph shows the total points earned for several pairs of shoes. We want to find the rate of change, which is our slope, and the initial value, which is our b, and then write the equation. So again, looking at the graph, this x-axis goes by ones, but this one is going by 30s. So pay attention to that as you're looking for these. So first of all, let's find our rate of change. You can either use 2 points, say 260 and 490, so 260, 490, and use the slope formula, y minus y over x minus x, or you can see that it goes up 30 over 2, paying attention to the axes, up 30 over 2, which is 15. So you can do this a couple ways, either using the slope formula or just counting rise over run. And we get that our slope or our rate of change is 15. So that's the first part. Then we have to find our initial value. So our initial value is when x equals 0, what is y? And when x is 0, you can see that y is 30. So the initial value, or the y-intercept, is 30. And now that you have the slope and the y-intercept, slope which is 15 and the y-intercept is 30, all you have to do now is plug it into the formula, just like we did before. So you can fill in those spaces in boxes on page 275, and we're going to look at another example together. So if you look at this one's not in your book, so you can just follow along. Music Inc. charges a yearly subscription fee plus a monthly fee. The total cost for the different number of months, including the yearly fee, is shown on the graph. So for 0 months, the initial fee then, this would be our initial fee, our yearly subscription fee, you can see is kind of between 10 and 15. And then for 1 month, your total cost is $15, 2 months, $18, and so on and so forth. So make sure you kind of understand what each of those things represents. So then, let's see here. Hold on a second. Okay, here. All right, so then our initial cost, our y-intercept, our b, is 12.5 or $12.50. Halfway between 10 and 15 would be $12.50. So this is that yearly subscription fee. And then to get from one point to the next, if I am going from, say, let's go on 2 even points. So let's go from here. If I go from this point to this point, I'm going up 5 and over, over, you can see here, that goes over 2. So 5 on the y, our vertical change is 5, our horizontal change is only 2. So this is $2.50. So that means it's costing us $2.50 per month for the monthly fee. So we said that B was $12.50. Oh my goodness. It's like, doesn't like me at all. B is $12.50, and our slope was 5/2, but in this case we wouldn't leave it as a fraction because we're wanting to write a function that makes sense. So $2.50 makes more sense. MX plus B. So $2.50 a month plus that $12.50 cost is how much it costs for this yearly subscription here. And this is our equation. And that's all we're doing for this one. So now that you've had a couple examples, go to page 275 and I want you guys to do all three parts of that check problem on page 275, and we will check this together. And you can stop now. This is all we're doing for today. Your homework is going to be part 2 of this video. So when you look, just kind of pay attention to the time here, and that's where you're going to start the next part. Okay, welcome back to part 2 of section 5.3, and this part starts on page 276. So you guys can go to page 276, and again, we're really doing a lot of the same things we did in the last chapter with writing equations, but now instead of calling them equations, we're calling them functions. It's almost exactly the same thing though. So that's the nice part. With these functions, we looked in the first example of finding the equation or the function from the graph. You should also be able to construct the function and write this equation of the function from a table. So if you remember, last time we used the table to find the slope. We looked in the last chapter about how to find the slope from the table as well as the initial value. So just take a minute, and on page 276, we're going to watch this video, and there are several boxes on page 276 for you guys to fill in while you watch.
To write the equation of a linear function from a table, start by finding the rate of change, or slope, of the line. The rate of change is equal to the change in y divided by the change in x. Choose any two sets of values from the table and use them to find rate of change. Subtract to find the change in y values, and subtract to find the change in x values. Then simplify. Next, find the initial value, or y-intercept. Begin by writing the slope-intercept form of a line. Y equals mx plus b. Substitute the value of the slope for m. Next, choose any pair of x and y values from the table. Substitute them for x and y. Then simplify. Solve for b by using the subtraction property of equality. Subtract 15 from each side of the equation. The value of b is the y-intercept, or initial value. Next, write the equation of the linear function. Substitute the rate of change for m and the initial value for b. The resulting equation represents the linear function shown in the table.
Okay, so this is a little bit different from the last chapter, because in the last chapter you guys were always able to find b from the table. You always had the x coordinate when x equals 0. You had the y coordinate, which was your y-intercept. But in this case, we don't have the y-intercept in the table, so it's going to be a little bit more work to find that y-intercept and make it. So look on page 277, and this is example 2. We are going to look at this table, which shows how much money Ava has saved. Assume the relationship between the two quantities is linear. So in 3 months she saved $110, 4 months she saved this much, so on and so forth. We need to come up with the equation of the function. Okay, so we can take any 2 points here on this table, and if you just want to keep it simple, you can just take the difference between these two, and what's happening here is it's going up 20, and here it's going up 1, so we can do 20 over 1, just like we did before. The difference, the change in y is 20, the change in x is 1. So our slope, our rate of change, is 20. But now to find the y-intercept, this is going to be a little bit different than what we did before. Because x equals 0 is not in the table, we're going to have to use the method that was shown in this video. So here is what we're going to do. We're going to take this equation, y equals mx plus b, and you can follow on the steps in the middle of page 277 and fill this in. And we already said that the slope is 20, so we're going to put 20 in for m in this equation. And then I'm going to go back to this table and pick any point. So we'll just choose the first one. It doesn't matter. You can use any of these points though. And x is 3 and y is 110. So in place of x, I'm going to put 3, and in place of y, 110. And then you see that the only variable left is b. So now 110 equals 60 plus b, and then we would subtract 60 from both sides here to get that b equals 50. So our y-intercept is 50. So initially, she had saved $50. So now we have the slope and we have the y-intercept, and those are the only things we need to write the equation. So now that we have each of those pieces, we'll just put slope there, y-intercept there, and there's your equation. Let's look at another example. This one is not in the book, so again, you can just follow along here. But the two things we need, this table shows the distance Sergey walked from his school as he rides his bike. We'll assume it's the relationship is linear. So now if you can see this, what is happening here is this is going down. Oops, let's see if this will work. This goes down 40, right? And this one is going up 10. So the slope is negative 40 over 10, which is negative 4. You guys see that this is going down, down, down. So the slope is negative 40, but this is going up 10, so negative 40 over 10. So the slope is negative 4. So that's our first part. Then we want to, so the rate of change is negative 4, and he is negative 4 meters closer to school. Oops, 4 meters closer to school every second. Now the initial value we have to figure out here. So we'll use this equation, y equals mx plus b, and I'll just take this first point. In place of y, we're going to put 1640. In place of m, we said that was negative 4. X is 10, and then plus b. So solving this equation for b, this will be negative 40 plus b, and then we would add 40 to both sides to get that 1680 equals b. So our initial value, the initial distance from school, is 1680, and he gets closer and closer every second as he's riding his bike. But our initial value is b, and our slope is negative 4, so we could say y equals negative 4x plus 1680. So the equation, once we find the slope and the y-intercept, plug them in to write your equation. So now you guys can try this on page 278. There is a check problem there. So make sure you do that check problem on page 278. Again, I will be checking this in. Show your work, and in that pause and reflect on the bottom of page 278, draw your best snowman for me. So again, just to make sure that you are watching, I want to make sure that you're watching these all the way through, and this is just a quick way for me to check that. So on the bottom of page 278, draw for me your best snowman. All right, you can stop here for now and pick it up next time. Okay guys, this is the very last example for section 5.3, and we are going to start on page 279. So you guys turn in your books to page 279, and we are going to write equations, same thing as we've been doing the last couple of videos, writing the equation in the form y equals mx plus b, but instead of having a graph or a table, in this case all we have is a verbal description. So watch this quick video and fill in the boxes on page 279 as you are watching.
A skiing instructor charges an initial fee plus $30 per hour for lessons. Tasha paid $205 for 6 hours of instruction. How could you construct a linear function from this description? Start by finding the rate of change. The rate of change is given in the problem. The rate of change is the hourly rate for lessons. Since it costs $30 per hour for lessons, this is the rate of change. Next, find the initial value. In this case, the initial value is the initial fee for skiing lessons. It is not given in the problem. Because the rate of change is constant, the relationship in the problem can be modeled with a linear function. X represents the time in hours, and Y represents the total cost of skiing lessons. Substitute the rate of change for the slope, m. The problem gives a value for x and the corresponding value for y. Substitute these values of x and y into the equation. Then simplify and solve for b. The value of b is the y-intercept, or initial value. The initial value is 25, so the initial fee for skiing lessons is $25. You can use the rate of change and initial value to write the equation of the linear function. Substitute 30 for m and 25 for b into the slope-intercept form of a linear equation. The linear function is y is equal to 30x plus 25.
Okay, so these problems do get a little bit more involved, and you have to think a little bit more. So just pay attention as we do a few examples. This one is on page 280. It says Joanne plans to add 12 photos to her album each week. After 8 weeks, there are 120 photos in the album. Assume its linear relationship. Find and interpret the rate of change, which is your slope, m, and initial value, which is your y-intercept, b. Then write the equation of the function, where x is the number of weeks and y is the total number of photos in the album. So there are a few pieces of information that we have here. Since we're told she adds 12 photos to her album each week, the rate of change is 12. So that's our very first step. Our rate of change is given to us, our slope is given to us. However, we don't have our initial value. And so you can fill in these boxes on page 280. We'll start with our equation. We know that our slope is 12, so we're going to replace m with 12. And then we also know that after 8 weeks, we have 120 photos. So we can replace x with 8 and y with 120. And again, just like in the last example, the only variable left now is b. So using the information we were given, we have the slope, one value for x and one value for y, which we can then use to find our initial value for b. So initially, she had 24 photos in her album. That's what that means. When x is 0, what is y? In this case, when x is 0, after 0 weeks, she's starting with 24 photos in her album, and then she adds 12 per week to end up with 120 after 8 weeks. So now that we have the slope and the y-intercept, finding those two pieces is the hard part. Writing the equation is easy. The slope goes here, and the y-intercept goes here. I think it was 24 if I remember correctly. And that's all you have to do to write the equation. So the hard part is finding each of those. Writing the equation should be easy. Again, not in your book, but look at this problem. And let's read and do this one together. Each week, Sam works the same number of hours. Her first week included an orientation. The total number of hours that she worked after the second, third, and fourth weeks was 20, 28, and 36 hours respectively. Assume the relationship is linear. So this one's a little bit different because they don't give us the slope. It's kind of like almost like they're giving us a table. It's like a table where x is 2 at 2 hours, or excuse me, after the second hour, or excuse me, the second week, 20 hours. After the third week, 28 hours. After the fourth week, 36 hours. So what is her change per week? Well, she's working 8 hours each week. So the rate of change in this case, can you guys see that? Is that each week her hours go up. So she's working 8 hours each week. And that is our slope. Now we have to find the initial value. Well, again, we don't have the initial value, but we have the slope, and we have, let's say, 1 point. If this was x, after the second week she worked 20 hours. So in this equation, we could say that y is 20, because y is the total number of hours, and x is the number of weeks. So 20 hours after 2 weeks, and the slope was 8. So we'll put in 8 for m, 2 for x, and 20 for y. And then again, solving this equation for b, we could subtract 16 from both sides, and we get that b equals 4. So m is 8, b is 4, y equals mx plus b. So this whole section, we're doing the same thing, writing these functions, the equations of these functions, but we have different scenarios. We have a graph, we have a table, we have a verbal description. In each case, you need to find m, you need to find b, be able to interpret what each of those represents, and then also write the equations. So her initial orientation was 4 hours, and then she works 8 hours each week, and so this function will tell us if she works 5 weeks, how many hours is she going to work? If she works 10 weeks, how many hours is she going to work altogether? So now you guys can, at the bottom of page 280, do that check problem. And at the bottom of page 280, let's see, what can you do? Draw the Star of David next to that check problem on the bottom of 280. So that'll be all for this section, and you might see some of these problems again or similar ones on your quiz on Friday. That is all. Have a great evening, afternoon, whatever it is, whatever time it is that you are watching this, and I will see you guys next time.